first of all, the first 4 examples here are just basic arithmetic combinations. Not a big deal. You guys did this last year, just a quick refresher. If you are adding together 2 functions, f and g of x, that's the same thing as just taking the first function, f of x, and adding it to the second function, g of x, and we'll go through some examples of that in just a minute. But if you are subtracting the functions f minus g of x, you take the first function f of x, you subtract g of x from it. We'll go over an example of that also. F g of x, that just means you take the 2 functions and you multiply them. F divide g of x, that just means you take the 2 functions and divide them. I don't think that that's a huge deal. That's probably going to be pretty easy for you guys to work through. Examples, f of x, if I tell you that f of x is 2x plus 5, and that g of x is x squared plus 2x plus 1, and I ask you to add the 2 functions, see the plus sign in between f and g, that means you add f of x to g of x. So f of x is 2x plus 5, g of x is x squared plus 2x plus 1. You need to add them together. So all you do when you are adding 2 polynomials together is collect like terms. You collect like terms. So we have an x squared. I'm putting that first because that's the highest power. And when you add polynomials together, the highest power always goes first. Does anybody remember what that is called when the highest power goes first? Say that again?
Order of operations.
Order of operations, not order of operations. It was a fancy word that you learned last year. Order of operations you learned years and years and years ago. It's called standard form. Do you remember that? Standard form. Highest power first, then the next highest power, then the next highest power. So we have x squared comes first, and then you add together the two x's. 2x plus 2x is 4x, and then you have a 5 and a 1 that have to be added together to give you 6. Yes?
That's quite a fancy term. You're right.
Okay, thank you. All right. Now, please, please, please listen to my explanation about minus. You guys certainly all know how to do the subtract ones, but please listen to my words. Please, please, please. It says to take f minus g of x. That means you write down f of x first, which is 2x plus 5, minus g of x. Notice my use of the parentheses. You're taking that first function minus the second function. The reason I'm making a big deal about this is because this is an easy operation to use, but there's one little thing that students quite regularly will screw up. Do you see the minus sign?
Yes.
The minus sign in between it. That minus sign has to be distributed into that second polynomial. So that minus sign needs to go to the x squared, it needs to go to the 2x, and it needs to go to the 1. That means that you are subtracting the entire polynomial, not just one of the terms. So I rewrote the first polynomial, 2x plus 5, but I have to subtract the x squared, I have to subtract the 2x, and I have to subtract the 1. Now, let's say that in g of x, in this polynomial right here, let's say that the plus 1 was not a plus 1, it was a minus 1. If it was a minus 1 and I distributed a negative into it, then it would become a positive. So what I'm trying to say is that everything in that second polynomial is going to become exactly the opposite of what it once was. Does that make sense?
Yes.
All right. F times g of x. F times g of x just means, of course, that you multiply the 2 polynomials. So again, use of the parentheses is pretty important. 2x plus 5 multiplied by x squared plus 2x plus 1. Now, you need to take the first term of the first polynomial, 2x, and you need to multiply it into the second polynomial. But you have to multiply everything, and you have to multiply the 2x times everything in the second polynomial. So you do 2x times x squared. That gives you 2x cubed. Notice when you are multiplying polynomials, the powers change. Do you understand that? You're adding the powers together. So you have a second power that needs to be added to a first power. So you get 2x cubed. And then when you do 2x times 2x, 2 times 2 is 4, and when you multiply an x by an x, you get x squared. And then you do 2x times 1, which is 2x. When you're done with that, though, I'm going to delete here. When you're done with that, then you need to move on to the 5. And you need to distribute the 5 to each of the terms in the second polynomial again. So we have 5 times x squared. That gets me 5x squared. And then you have 5 times 2x is 10x. And then you do 5 times 1, which gets you 5. And now you're just stuck with a really long polynomial. So now you need to start collecting like terms. You add the squareds together, you add the x's together, and so on. I started off with a 2x cubed because that is my highest power. 2x cubed comes first. Then I added together all the squareds. So you have a 4x squared and a 5x squared, giving you a total of 9x squared. Notice that when I'm adding the terms together in the end, I do not change their powers. So we have a 4x squared and a 5x squared added together give you 9x squared. The square did not change. Now we have 2x and 10x, giving me a total of 12x, and then I have a plus 5 at the end. The divide. Now in this case, this is a really nice example because when you take f of x and divide it by g of x, f of x is 2x plus 5, g of x is x squared plus 2x plus 1. That's all you can do. You can't clean that up at all. There's no like terms to add together and so on. You're just taking a polynomial divided by a polynomial. There is nothing that is common to the top and the bottom. Now some students might think, oh well, there's an x right here. Can I cancel that x out with the x right here? You cannot do that because the 2x is being added on to 5. If these two things are being added, there would have to be the 2x plus 5 would have to show up in the bottom 2 as a factor. You would actually have to have 2x plus 5 right next to the x squared plus 2x plus 1. You'd have to have that on the bottom in order to cancel out the whole thing. That is not there, therefore you can't. You may remember that a little bit from last year. So when you divide these two, in this case, can't do anything else with it. Your answer is 2x plus 5 over x squared plus 2x plus 1. All right. Let's move on to something a little bit more difficult. Compositions of functions we'll get into in just a second. F plus g of x when x is equal to 2. So when now you have to look back in your notes. When you added together f and g of x, you ended up with, I believe, when you added f and g of x together, help me out here, you guys, was it x squared? X squared plus 4x plus 6?
Yeah.
That's what you got when you added together f and g. So this is your simplified expression. What I'm asking you to do is evaluate f plus g of x when x is 2. So you take that 2 and you plug it in for each of the x's. So you get 2 squared plus 4 times 2 plus 6 giving you a total of 18. So you add the polynomials together and then you start plugging in the value of x that you're working with. F times g of x, figure out what that is when x is equal to -3. It's on the previous page, I could scroll up, but was it 2x cubed plus 9x squared plus 12x plus 5? Is that what it was? Alright, so all you need to do there is take this value of -3, you need to plug it in for all of your x's and get an answer of -4. Probably not a big deal. Alright, composition of functions. This is that weird notation that we were talking about a few moments ago. The composition of the function f with the function g is f o g. Actually, it looks like an O. This little symbol right here is a composition function. It looks like an O. It looks like it spells fog. It does not. The little O in the middle is much smaller. It's just a very, very small circle of x. Now look what that means. F comp g of x really means, this is the important thing right here, this is what's going to mean more to you, f of g of x. That's what f comp g of x means. It means finding the value of a function given another function. That notation looks weird. I'm hoping that once I talk about this, it will make a lot more sense. So first of all, when you work with a composition like this, start with the inside function first. So we're going to start with g of x. So really what you're doing is figuring out what is the value of a function at g of x. So if you are looking at just f of x, of some function x, we always call the x's the domain. So in this case, the domain of f of x, in this case right here, the domain of f of x is g of x. So f of g of x, this part right here, g of x, I have noted as this is the domain of f. And then the answers that I get out of it will be called my, what's it called when you get answers out of something? Out of a function. It's called the range, yes. Now, if you are just looking at g of x, the domain is the x values as we talked about earlier. So, an example of this, if f of x is equal to x squared plus 3 and g of x is equal to x minus 2, and I'm asking you to calculate f of g of x and g of f of x, this is what you will do. So first of all, f of g of x. We're going to do this one first. F of g of x. Now remember, f of g of x is equal to this notation right here. And I remember a minute ago I said you guys work with the inside function first. So I'm going to circle g of x. Well, g of x, I told you, is actually x minus 2. So what we're really doing is figuring out what is the value of f when I replace the input value with g of x, which is x minus 2. So I'm going to take this x minus 2 and I have to plug it in to my x value in f of x. And the x value in f of x is x squared. So I take this x minus 2. Remember how the function f of x was x squared plus 3. So all I'm really doing is replacing this x with x minus 2. So I put it right here. I have to square it, and then I have to add 3. So x minus 2 squared. Well, x minus 2 squared, you guys know, really means x minus 2 times x minus 2. You need to multiply that. FOIL it. So you're going to do x times x, which is x squared. And then you're going to do x times negative 2, which is negative 2x. And then you're going to do negative 2 times x, which is negative 2x. And then you're going to do negative 2 times negative 2, which is positive 4. Well, when you collect like terms there, you're going to end up with x squared minus 4x plus 4 plus the 3 at the end. Don't forget about that 3 at the end. That gives you x squared minus 4x, add the 4 and the 3 together, that gives you 7. Now if I ask you to do this backwards, g of f of x. G of f of x. Well, the g has to go on the outside now, and the f of x goes in the middle. Well, what is f of x? F of x is x squared plus 3. So I'm going to take this x squared plus 3, and I'm going to plug it in to there. And what I need to do now is figure out what is the value of g of x when I replace the x value with x squared plus 3. So g of x, remember, g of x is equal to x minus 2. So I just take this x value and I replace it with x squared plus 3. So this x right here has to be replaced with x squared plus 3. So I put an x squared plus 3 in it, and then I subtract 2 at the end. When I do that, 3 minus 2 is 1. So I'm left with x squared plus 1. Questions? Does it look horrible?
Yeah.
Does it seem horrible?
Not a little.
A little bit? Okay. Anything you want to ask me before I stop? Yes.
Are we ever gonna have to like do it backwards? Like take the solution and you try to figure out the two functions.
No, I don't think so. I don't think so.
Possible.
That's a good question. Could you work backwards and get the original function? I'm sure somebody could do it. I don't know off the top of my head.